Hi, everyone. I'm Jennifer Chow. I'm Redfin's VP of Engineering. I'd like to welcome everybody here for our fifth Tech Talk. I want to introduce Robert Gay. He's Principal Engineer on our Platforms Engineering team. Our Platforms team is roughly 10 engineers who are really dedicated to developer happiness here at Redfin. And I would say at the beginning of this year, when we surveyed, we have a quarterly engineering survey, and we surveyed the engineers, and build pain was at the top of the list. So this has been a big area of focus for us this year, and I'm happy to say that in our most recent survey, it was no longer the top item. It was much further down on the list. And so Robert's here. He's going to talk about some of the things that we've done to improve our build.
Is this working? It is now. Exciting. All right. So thanks everybody for coming to listen to me talk. I really appreciate it. It would be weird if I was standing here and there was nobody in the audience. So you came to listen to me talk about Webpack build performance in large projects. I like to think Redfin's project is pretty large. So hopefully something I have to say will help you take it back to your companies or get started or make yourself or somebody you know happier that uses Webpack. The talk is divided into roughly 3 categories. I'm going to talk a little bit about like sort of Webpack in a backgroundy sense. I assume that most of you are probably pretty familiar with Webpack if you're here, but I just want to make sure we're all sort of on the same page to start off. The meat and potatoes of the talk is a scripted choose your own adventure game. If that sounds different, it is, I promise. And then there's some stuff at the end that isn't Webpack specific, but affects developer happiness and build performance in a lot of ways that I wanted to touch on as well. So without further ado, Webpack. Are any of you here wondering what Webpack is? Okay, well, so I was gonna say this talk might be difficult. But in all seriousness, so Webpack is a module bundler. That's its primary goal, its primary purpose. It takes multiple files, your JavaScript files, your CSS files, whatever, and combines them together through fanciness and code into one or more output bundles. This is commonly used, or most commonly used, for the browser, but it can actually target a variety of different platforms. You can have Webpack output bundles specifically for Node. I believe that they're commonly used for Electron apps, which I don't know if you knew this, but all of the apps you're using now are Electron apps under the hood. It's scary. Slack, that sort of thing. Webpack, in addition to bundling, can do transforms on your source via what it calls loaders. It's a strange name, but it works. And this isn't just for JavaScript. It can transpile less or Sass style sheet, sort of high-level style sheet languages down into something that the browser can use natively. Webpack's also extremely pluggable. You can extract, or there's a plugin that allows it to extract common code out of all of your the code that would be used for multiple pages into a single bundle that they can all use. There's a plugin for minification. There's a plugin for pretty much probably anything that you would want. And you can write your own. Why would anyone choose to use Webpack? Module bundling, obviously. It's extensible, like I just said. There's also a very large community. And I think in the last probably 8 months or so, that community has sort of gone gangbusters. There's a significant focus on Webpack performance. There's a lot of work being done to try to address issues like in documentation and the code itself, I guess, to make Webpack more approachable and easier to use and things like that. So it's an exciting time to be using Webpack. Webpack also has a pretty significant portion of the module bundling mindshare. If you troll around the internet, you would be there are other module bundlers, but you would be hard pressed to find one that has as much documentation or as much engagement, I guess, as Webpack does. That's all I'm going to say about Webpack itself. Here's the meat and potatoes of the talk. Webpack performance. A scripted choose your own adventure game. So the setting is present day, roughly. You are a developer for a company that writes software, probably. Your mission is to set up a JavaScript build for the company you work for as it transitions from an older technology stack. By the way, this whole thing may or may not be roughly based on a true story. You pick Webpack for your module bundling because of all the reasons we just talked about. And the first thing you do is slap together a pretty straightforward, simple, basic Webpack config. It has an entry point that defines the JavaScript that'll be used for the homepage. It defines some sort of metadata about how the output will be written, where it'll be written, what the name of the files will be, that sort of thing. You also include an entry for it to generate source maps to make debugging for developers easier. We discussed loaders a little bit. You obviously include one that'll use Babel to transpile your ES 2015 code, your like latest and greatest JavaScript syntax, into a format that the browser can understand. Use Babel loader. It's the name of the loader. It's pretty self-explanatory, I think. You apply it to JavaScript or .js or .jsx files. And because you were reading the Babel loader documentation and all of its examples exclude node modules, you do that too. There's no reason to transpile code that's you're being given from some external npm package. They probably did this already if it was necessary at all. You also want to set up the ability to extract style sheets from your code. So you use the extract text plugin, which at some point actually came out of beta. I was really shocked. It's pretty straightforward. It's a little more complicated than the Babel loader. It requires both a loader that does the step of identifying and pulling the style sheets out of the module itself, and then it requires a plugin that will concatenate that all together into an output file and write it into the appropriate place. That's what it looks like. There's 17 lines in the file. That's it. You got a basic Webpack config. There's an entry point for your homepage. There's some output bundle metadata. You've got some Babel transpilation going on, and you have the ability to extract style sheets into a separately cacheable bundle. That's the end of the talk. Thanks, guys. No, I'm obviously not. The first thing that someone asks for after you show this to them is, so we want to do server render too, and you just gave us a client-side bundle. How do we do this? Well, it's not uncommon to want to use Webpack on the server side as well as the client side, or to create a bundle rather that runs on the server. It's convenient to have the same technology do this on both places. So you copy your file into a file called webpack.server.js, very cleverly named. You specify a target. I mentioned this earlier. It's not really that important. And then the other thing you have to do is tell it to ignore less files. You don't want it to be doing anything with style sheets on the server. You also then take your original file, which was called webpack.config.js for the client, move it to webpack.client.js because it's a much more clever name. And because Webpack wants you to have a file called webpack.config.js, in this case, that file, we will create it. It will only point to, the only thing it's going to do is point to those two separate Webpack bundles that you created, or sorry, Webpack configurations that you created. If you run the Webpack tool, Webpack understands this array. It knows that it's supposed to build both of them and follow the appropriate, put the output in the appropriate places, things like that. We covered this. Oh, the one thing that we didn't cover, or that I didn't cover there that isn't in the screenshot because the screenshot was already too small, is in addition to telling the less loader that you don't, or sorry, in addition to telling Webpack that you want to ignore less files that it encounters, you also need to remove extract text plugin from the plugins array. It's not going to do anything. There's no reason to keep it there. And you file away for a future enhancement that there's a lot of a lot of common configuration between the server and the client Webpack configs. And it turns out that there's a package that somebody's written that can help abstract some of that away. So you can share a common core of configuration and then use it, sort of overrides certain subsets of it or whatever. And that package is called Webpack config. We have server rendering, we have client bundles. Time to go to production. You ship a prototype, and it's pretty clear from the get-go that you forgot something. this is your client bundle. Does anybody know what's wrong with this client bundle? Yeah. It's not minified. Why Webpack's including 10 characters of comments on every line in addition to including all the comments from the code. This isn't what you want. We forgot minification. Webpack has a plugin for that. It's the Uglify.js plugin. It comes with Webpack Core. They ship it as part of the thing that you install. We only want to do this when we're bundling for production. So we will use this process.env.nodeenv environment variable to control whether or not it's in use. We won't do that in dev environments. We'll only do it for production builds. I added this little clean function. You can pretty much ignore it. All it does is when that nodeenv equals production and Uglify.js plugin returns false, it just pulls it out of that array. Just ignore it. Now we're done. Thank you, Dan. That was a lovely clap. So we're finished, right? We got server and client builds. We got Babel loader excluding node modules for performance. And we have Uglify running in production. And maybe we actually are done for a while. We've got a homepage. Maybe we're done for a lot of whiles. But eventually, the goal here was to transition our code for the company from an old technology stack to a new one. And that means we're going to be onboarding more developers. We're going to be adding more pages. There's not going to be love stock photos of people that work here. We're going to be onboarding more pages. We're going to have more entry points in that Webpack config. We're going to be generating more and more and more code as part of the output bundle. Until eventually, one day, you're going to overhear somebody say at lunch behind you. Maybe they intended you to hear. Maybe they didn't. Why are my builds so slow? Why do I have to wait so long for this? You sense an impending mutiny. Your job is on the line here. Your new mission, should you choose to accept it, is to squash these build performance issues as they crop up as fast as possible. Unhappy developers, not good for business. Also not good for you. You are their only hope. And their expectations are pretty high because that old system that you're transitioning from, all you had to do was change a JavaScript file and refresh the page, and it would just show up. So what do? Developers are spending time waiting for builds. You have 4 options. You could do less work. You could do more work in parallel. You could distract them with something shiny. This works pretty well, actually. Or you could increase the node heap size. You laugh, but it's so true. You decide to start by doing less. You remember from the Webpack docs way back when you were first setting things up, when you chose that source map attribute, the cheap module eval source map. It might be a little hard to see, but the initial build is supposed to be about the same time as something. And the rebuilds are supposed to be pretty fast. But you never actually thought to measure what that difference is. And you didn't have any code, so how would you know what the difference is? So you add a flag to disable source maps. It's pretty easy. It looks a lot like that flag to turn on Uglify. You just, we'll have an environment variable. When you set it, we won't include the source map option. And you save 25% off your build times by doing this. That is what we save today at Redfin when you turn off source maps. All of you that have source maps turned on, Redfin folks, this is what I'm trying to tell you. But source maps can be nice. You can't have them turned off all the time. There's a question in the back. The question was, what about debugging? And the answer is, it's all JavaScript, even when it's transpiled, right? Anyway, no, but seriously, source maps are nice sometimes. They provide a valuable service. Sometimes it's worth it to pay that price to generate them. So you did something, but it's not enough. You need to do some more. You need to do less work, more work in parallel. Is it time to distract them yet? Or will you increase the node heap size? We tried doing less work, so now we'll try parallelizing some things. You Google around, ask some questions, find some people who know more about Webpack than you, and somebody mentions parallel Webpack. That sounds like exactly what we want, am I right? So parallel Webpack builds Webpack configs in parallel using the worker farm node library, which is really hard to use itself, but parallel Webpack abstracts all that away, and all you have to do is give it Webpack config. It is basically a drop-in replacement for the Webpack command itself. We created this file that exports an array of Webpack configs earlier in this talk. Just give that to parallel Webpack, and it'll do the right thing. It'll build server.js in one process and client.js in another process in parallel. Why not? Add it to your package.json with yarn add, because everybody uses yarn and not npm these days. And whip up a toy demo to show the output to your friends. It looks like this. When it's actually in the output, you can't see, but those were two separate processes, I promise. See, it says started building and started building at the same time. You breathe a sigh of relief. You just significantly improved the build performance. And your sigh of relief is cut short by an IM from a coworker saying, hey, how come when I run my builds in the continuous integration environment on Jenkins, it's way slower than when I run it on my local machine? Why are these different? They're the same. They're doing the same work, right? Except for that one thing that they're doing differently. Uglify. Uglify only runs when we're running in a continuous integration environment, getting ready to deploy to production or to a staging environment or something like that. Uglify is causing things to get ugly. What are you going to do about it? I claim that turning off Uglify is not an option here. And I claim that the thing to do is to try and do more work in parallel. You think to yourself, Uglify is a CPU-bound operation. We're taking big JavaScript bundles and we're running transforms on them that take up a bunch of CPU. And this is all running in a single process because it's Node. So what are you going to do about it? I claim what you do is remove Uglify.js plugin from your plugins list in your Webpack config. You add a make file that calls Uglify and passes in all of the output bundles. And then you run the Webpack step and then separately run the Uglify make file that runs everything in parallel. Make is really good at running things in parallel. All right, you probably don't do that. You can, though. You can. And I say that because we do right now. That is what we were doing. Partly, not our fault, because they only recently added to the Uglify.js plugin the ability to use a worker farm like Parallel Webpack does, where you can say, hey, I want you to farm out these Uglify processes, or sorry, I want you to farm out these Uglify invocations to separate processes. So each bundle gets done in a separate process within reason. By default, it uses number of processor cores -1 so that you can have your Webpack building and also be Uglifying. Seems like a reasonable default. I picked 2 because I like 2. They also added the ability to cache the output. So if you previously built a bundle and the bundle hasn't changed, you don't need to build it again. It's pretty slick of them. I kind of appreciate it. We wrote that make file, which does all the work that this does, but differently. So I kind of lied when I said we're not going to do less work, right? Because we also got the caching here. So if you happen to be running in a local dev environment needing to Uglify because you're trying to reproduce a bug where it's stripping things that it's not supposed to, it actually will do less work the second time you run it because it's using those the cached output. Parallelizing Uglify significantly improves the Jenkins build performance. I don't have exact numbers, but it was significant, like on the order of minutes on an 8 or 9 minute build. It also improves local builds using minification in the way that I just said. We have cached output, so we don't have to re-minify things that haven't changed. Another sigh of relief. Pull up Redfin on your phone, check for houses that have come on the market in your neighborhood. Still can't afford them because it's San Francisco. And you look at some stock photography of beaches because San Francisco is pretty foggy in August. and then you get back to it. You're not done yet. You're on a roll. You want to keep this progress going. You start thinking, maybe there's somewhere else we can do less work. Uglify had this thing where it cached intermediate output. Wouldn't it be great if Webpack could do that? Well, Webpack can't yet do that. But as you muse to yourself out loud, what sort of things could I cache? Because you're in an open floor plan office, or mostly open floor plan office, you muse to yourself when you want somebody else to answer the question for you. And a coworker from the back of the room yells, Babel, cache Babel. That's where you're doing all your work, silly. And if that didn't cause the light bulb to go off, I would be really shocked. So obviously it does. You go to the Babel Loader docs, and you find this section that's way too far down the page for what it says. You can also speed up Babel Loader by as much as 2x by using the cache directory option. This will cache transformations to the file system. You have a lot of files, and you're doing all that work over and over and over again. Why not cache the intermediate results to the file system? So you're pretty amazed that this exists and you didn't know about it. And you dig in, it's going to be a tough one. It's going to be really hard to implement. You add the cache directory true property to your Babel Loader options, and magic happens. You're not allowed to have the big exploding fireworks, so you settle for sparklers, which are also probably illegal, but that's what you had on hand. And this cuts your non-initial build times, so I can't say rebuild, but your incremental build times by up to 50%, depending on the number of files that you're transpiling. This is what, I measured this. This is what happens if we build our stuff with Babel in full every time. I would have been murdered by now if we hadn't done the equivalent of this. You write a blog post about your findings, and you caution in the blog post that the reason that this isn't on by default might be because for small projects, it doesn't make a lot of sense. It's actually just as fast to read from the file system and transpile them as it is to, it's just as fast to read the raw source from the file system and transpile it as it is to read a gzipped file, which is the format that that Webpack stores, and unzip it and actually pass it through the loader. But man, for large projects, this is significant. You're still not done though. Will you do more in parallel? Can we do more in parallel? Can we do less work? Is it time to distract them yet? Or will you increase the node heap size? It's time to increase the node heap size. You laugh, but you increase the node heap size while you're laughing. And then you think to yourself, wow, how did we get to a point where we have to do all of these other things in order to make this build performant enough that you're not stabbed in the back by coworkers? How do we make it all the way here without ever having to increase the node heap? The answer is, in real life, you wouldn't. You'd have to do it a lot earlier than this. All right, heap's fine. There's still more to do. There's at least one more thing. Not going to increase the heap again. We just did that. Can't do less work. I claim that we're pretty close to doing the least amount of work possible. In incremental builds. Clean builds are still pretty rough. So what else can we parallelize? You stare at some stock photography of a bridge that might be famous. You're not actually sure. But the way the wires come down and hold everything up gets your wheels turning, your gears turning. And then you're struck by a flash of the obvious. All the JS for each of those two Webpack configurations is being built in the same process. Your client bundles are being built in the same process. Your server bundle is being built in the same process. Where's the parallelism? You ask your friend Google, hey, I'd like to build some stuff in parallel with Webpack. And it says roughly, use HappyPack dummy. HappyPack makes Webpack builds faster by allowing you to transform multiple files in parallel. This is exactly what we want. And why do we want it? Because Webpack initial build times are horrifying in large code bases with, say, 3,000 or more modules. You integrate HappyPack immediately, obviously. It's a little more convoluted than some of the other things. You replace the Babel loader with this HappyPack loader thing, which roughly says anytime you encounter a JavaScript file, Webpack, pass it off to this HappyPack thing. And then you add a plugin which sort of plumbs all that through. and says, hey, anytime that I receive a request for a JavaScript file, I'm going to run it through Babel. And then you push immediately to master because there's no reason your coworkers should have to wait for this incredible increase in speed. And then you sit back and you feel the wind on your face as your build completes with blazing speed. I claim it can't be faster than this. And you look back at where you were when you started down this path and you laugh to yourself. Performance was so bad before. You added a source map opt-out for people that like looking at transpiled code in the browser. You set up parallel Webpack to build all of your Webpack configurations in parallel. You parallelized Uglify.js, not with a makefile, but with this plugin that allows you to build everything in parallel easily. You cached the output of the Babel loader, and you integrated HappyPack for maximum Babel, parallelization. But you acknowledge that there's future work that could be done. We didn't actually integrate extract text plugin with HappyPack, partly because having two separate HappyPacks makes the configuration really hard to read, and I don't have that many lines on the screen. You should also investigate Cache Loader, which is called out in the HappyPack docs as like the thing you're supposed to use. But when you tried it just by dropping it in, it just exploded for reasons that you didn't really want to debug while you were working on this talk. And another thing that you observe is that as you've added more and more and more pages to Webpack, the number of entry points has grown. And your build time seems to be correlated with the number of entry points. Not necessarily the amount of code, but the number of entry points, which is a little sketchy. And then you turn to the audience and say, okay, I just told you all of my tricks for optimizing Webpack. What are y'all's secrets? What is like one thing that you've done that had a significant improvement to your Webpack build? Yeah. DLL plugin. All right, cool. What was the like sort of rough return on that?
I don't know the core idea of it. If you don't know what it is that it will take sets of code that are very rarely changed and allow you to precompile it. So you can precompile all your vendor stuff and remove modules so that you don't have to compile it every single time.
I want to talk to you afterwards because I tried that and we didn't get a benefit. So I'm really curious. I suspect that I screwed something up probably, but anybody else? Like, yeah.
Well, not necessarily question with it, but we have like remote caching, distributed caching, so that's sometimes like 10 to 100 times faster.
Got it. Okay, so if there was a way to get the intermediate results and store them somewhere else so that all of your developers can share them, everything? Yeah. All right. Cool. I probably should have repeated that. Sorry. The observation was distributed caching can be a huge win if you can cache intermediate results in a place that's accessible by all developers. I find it hard to believe that these 5 things plus maybe DLL plugin, and if we had a way for caching intermediate results is like all you need to have performant Webpack. All right, I'm going to leave it for now. Now we're officially done with this part of the talk. There's a little bit more. So I want to talk a little bit about other stuff. I'm going to drop the second person you thing now. So these things they don't fit in the talk because they're not specifically Webpack performance, but they had a big impact for us in terms of either developer happiness, not necessarily performance, but just in general, like making life easier for developers, or some of it is performance related. I'm going to talk about something shiny, which I alluded to over and over and over again. We did actually distract them with something shiny. They didn't even know it. I want to talk about the idea of lazy watch built on top of Webpack, which is something that is part of our core developer experience. I don't want to talk it up too much because somebody in the back of the room is going to yell that they don't like it that much, but it provides a pretty performance alternative to not having it. So there's that. It's sort of like the source maps things. You don't have to use it if you want your build to take 90 seconds every time you want to run it. And then I want to talk a little bit about I want to present perhaps an alternative worldview to the one that you'll get if you Google for like, how do I set up Webpack? Lerna is the shiny thing that we use to, it's not really distracting developers, but it is probably one of the best things that's ever happened for local development at Redfin. And it's not strictly about performance, although there is a performance component. And for those of you that aren't familiar, Lerna is a way of managing multiple JavaScript packages in a monorepo. So you have all your NPM packages checked into one Git repository, like Babel does this. And Lerna knows what the relationships between them are. And when you tell Lerna to bootstrap things, it can hoist shared dependencies to a shared location. That was redundant. It can hoist. Let me give you an example. If you have package A and package B that are both managed by Lerna, and both of them depend on Lodash 4.3 or 10 or whatever, Lerna will say, okay, you both depend on this. I'm going to hoist it to the root of the repository. I'm going to install it once. Both of you can see it because of Node's resolution algorithm, but it's a faster install process, and just somebody has claimed that it actually makes Webpack faster too, because there's only one instance of this to look at rather than Webpack having to find them in every package that you're installing and dedupe them. I don't have numbers for that, but I can't imagine it's not true. Yes. Oh, and the other thing that Lerna does with the internal packages is it will link them all together for you. So you don't have to run npm link ever. You say Lerna bootstrap this whole repository. A depends on C, B depends on C. Both A and B end up with a node modules directory that has C in it, a symlink to C, actually, which is really, really powerful. What we were doing before this was not this, and it was awful, absolutely awful. I'm seeing head nods. Like the alternative when you're managing packages in a monorepo is not great at all. And Yarn is supposed to come out with some features that are similar to this. I haven't seen them yet, although I've seen them talking about them. So that might be interesting too if you're already using Yarn. Yeah. All right. And I wanted to talk about Lazy Watch, which comes back to that idea that I mentioned of reducing the number of entry points that you present to Webpack. And this is sort of specific to, our implementation is sort of specific to Redfin just because of the way we build our code. But I think the general idea might apply in other places, and somebody might actually be able to generalize it further than I'm willing to. This is just a pattern, and it relies on you being able to map a path, like a URL, to a particular Webpack entry point. And the idea is basically when you start Lazy Watch, you expose all of your entry points to Webpack as empty files. You'd think that Webpack wouldn't like this. It actually doesn't care that much, which is pretty sweet. You keep track of which entry points have been initialized, and then you do this thing where you run a proxy in front of the whole business. That proxy intercepts requests and says, oh, you want /foo? Let me go ask the build, hey, has the entry point for foo been built? And if it hasn't, it returns a little message to you and sits there spinning, and it builds it in the background and then returns it to you when it's ready. But if it has been built, then it can just go through. It's transparent. And this is a pretty significant performance win for us. Our largest Webpack bundle takes 100 seconds, 90 to 100 seconds with source maps turned off. And it has 200 entry points in it, something like that. That it has 200 entry points. Don't ask why. With Lazy Watch, instead of taking that 100 seconds for the initial build, it takes 15. And then the first time you request to the homepage, there's like a 20-second wait while it builds the homepage, but rebuilds after that are much faster too because it doesn't have to look at any of the code from the other entry points. So this works pretty well for us. I sort of described this already, but if you're a visual person, I kind of am. So the request comes into the proxy. The proxy says, hey, you requested /foo. I'm going to ask this entry point manager thing, the blue box, has foo been built yet? Foo hasn't been built yet. So the entry point manager says, hey, build the entry points for foo. Files get written to the file system. Everything comes back to the proxy. The proxy allows the request to go through. Files are read from the file system and served. I'm happy to talk about this in more depth afterwards if anybody's curious. If any of you are familiar with Webpack Dev Server, you might be asking, hey, isn't this just the lazy attribute that you can pass to Webpack Dev Server? I think it is not. And the reason I think it is not, I struggled with this because I was sort of looking at both. I was evaluating whether we can use Webpack Dev Server instead of this. And the key difference is that Lazy Watch requires this proxy to understand the mapping of URLs to the entry points. Whereas Webpack Dev Server does the other thing and just says, hey, if you request an entry point and it hasn't been built yet, I'll build it for you. But if you don't know which entry point to build because you don't know which one's associated with the home page, that doesn't work. So it's a little different. And an alternative worldview. So if you Google online, like how to set up Webpack, basically everything's going to tell you, yeah, you should use Babel Loader. You should use, some things will tell you to use Happy Pack. If you find the good ones, they'll tell you to use Happy Pack. But they present a worldview that's very Webpack centric. Like everything should go on Webpack. You should use Webpack for everything. And that works pretty well if you have a project that's fairly well contained, or if you have like a development model that has all of your packages distributed and individual teams work on things and you manage them with like versions, pinned versions. But if you're developing multiple packages in a monorepo, it's kind of weird that you have this one package that has a bunch of Webpack config in it that's doing maybe Babel transforms, and then 40 other packages that don't. Maybe it makes sense to use the same build system everywhere. So potentially everything uses gulp. Not that gulp's that exciting or whatever, but maybe you use Babel directly. You build all this in parallel, potentially with Lerna. And then the only thing that you do with Webpack is the bundling. Somebody's got to put it in a format that you can load in the browser and do code splitting and do style sheet extraction. But none of that stuff makes sense outside of that one package. You get parallelism if you're building these packages with Lerna. It's going to build or bootstrap everything in the right order, using as many cores as it can, or as many cores as you let it. You get caching of intermediate results with Gulp. That's one of the things that Gulp actually does pretty well. And I think Babel, I want to say Babel will do it too. It won't rebuild files that have changed, or you can tell it not to. I'm entirely sure. And then a third worldview is that I'm totally wrong and you shouldn't be doing any work at all in all of these packages. And you should have Webpack do literally all the work, and all of your 40 or whatever NPM packages that you're managing in your monorepo shouldn't have a build at all. They should just export ES 2015 directly. And that's a possibility too. And then you get caching through Babel Loader and you get parallelization. This is sort of a pet peeve of mine, I guess. Thank you all for listening to it. So we talked about Webpack-specific perf improvements. We talked about non-Webpack perf and dev happiness improvements. I'm really curious to hear from you all after the talk, or now if we want to talk, as a group. What sort of things work well for your organization in terms of like keeping developers happy, keeping builds snappy, keeping things moving forward, and not getting bogged down in all the tooling? Because it's like Jen said, it's harder than it sounds a lot of the time. And yeah, that is all I got. Thanks for hanging out. Questions, comments? So the question was, what did we bump the heap size to? I think that there are two biggest Webpack bundle or builds right now are 4 gigabytes. And we had somebody try to increase it to 8. Put the kibosh on that. a lot of the heap seems to be used by source maps, actually, like full file source maps, which we're only using for. We have a series of tests that run on bundle sizes. So if you make a change that's going to go out with the next release, we can see, oh yeah, you increased the bundle size by 1 megabyte. Maybe we should, not do that. Or alternatively, hey, somehow we decreased the size by 10 kilobytes. Like, what happened? Is that normal? Did something not get included that should be? That sort of thing. But that was where we have a special case in there that's like, if we're running this test, we need to increase the heap a lot. Yeah. Others? So the question is, how many modules is our biggest Webpack config responsible for? And I meant to actually count that, and I don't know for sure, but it's quite a bit. I would be shocked if it wasn't 3,000. Somebody who works here, who I'm betting it's close to that, if not more. And this is, for context, this is the build that's handling most of the customer facing site. So there's a lot of pages involved there. Other stuff? Yeah. Similar, like, build performance issues. So the question was, do our iOS and Android teams have similar performance issues? I don't actually know. Is there anybody here from Redfin who would know the answer to that? We got a half-hearted no. Other stuff? Yeah. Yeah, so the question was about the performance of the bundles that's created, and that would be a separate talk. It's a different guy working on that too. We spend, Alan. Yeah, so we spent quite a bit of time recently, I think in particular, trying to understand like what the optimum size of the bundles is. I think I can probably say that everybody agrees that they're too big currently. Like, ours are pretty big, which we get away with but aren't happy with. We're pretty excited about, like, tree shaking in Webpack 2. So the idea that you can entirely cut unused code paths. I heard that it doesn't work quite as well as advertised, but I would love to see it work well. And then I know that there are people who've done work evaluating, like, how long does it take, in particular, the initial bundles that come down that can potentially block time to interactivity for the stuff that's above the fold on our website. So, like, if you go to a page about a house on Redfin, that stuff at the top that you see first, we want to be interactive as soon as possible, and we've been working on that, I believe. So the question was, do we find that we have similar performance issues running Webpack in watch mode, or if we also have performance issues running Webpack in watch mode? Yeah, so so the follow-up was, do people wait more than a few seconds for changes to happen? And I don't have the number offhand, but they can, yeah. That was actually another one of the reasons that we ended up with lazy watch mode as a pattern, was the Webpack bundle for that site, is what we call it. That Webpack config is so massive that there's a pretty significant rebuild time even with watch mode. It's 5+ seconds, I think, without lazy watch. Yeah, in the back. So the question was, have we upgraded to Webpack 3? And I'm glad that you asked that, because I was telling this story to somebody beforehand at dinner. So it was a little hard to hear, but it sounded like you were asking about, like, did we do it and did we have problems upgrading? We have a branch. It's a great answer, right? So we tried to upgrade to Webpack 2 when it came out, and our build performance got murdered, and we didn't know why, and we didn't have time to look at it. And then Webpack 3 was all about performance, so we tried to upgrade again to Webpack 3, and our build time was 10 seconds faster than it was with Webpack 2, and still 3.5 minutes slower than it was with Webpack 1. Couldn't figure out why until like 2 weeks ago, when we basically found via a profiler that all of our build time was spent with Webpack trying to stat files on the file system. So when Webpack's loading modules, it tries to append a file extension to look for the file on disk. Sometime between Webpack 1 and Webpack 2, instead of doing that in order of the array that you give it, it just picked all of them out of the array and fired them. So we have thousands of modules times however many file extensions we have that are all hitting the disk at the same time, and none of those extensions, not all of those extensions apply to any particular file. So anyway, literally switched a parallel in a function call to series, and all of our build performance came back. So that is the answer to how we feel about Webpack 3. As far as I know, as of like literally 4 o'clock this afternoon, we don't know of any issues with Webpack 3. We did have to also upgrade the extract text plugin. Without it, we got like weird style error. There's no error in the build. It just succeeded but was broken. But other than that, I don't know of anything yet. I'm sure we'll find it once we try to ship to prod. Yeah, Sasha. The question was, have we tried different versions of Node for performance? And the answer is yes and no, kind of no. Well, kind of yes. So when we were trying to upgrade to Webpack 3 and somehow went from a 2-minute build with source maps to a 5.5-minute build, one of the things that we tried was, hey, what if we do this with Node 8 instead of Node 6? Because Node 8 is supposed to be way faster. It wasn't faster. I haven't personally tried, I don't think, and I don't think the team has tried doing a newer version of Node after we fixed the significant performance bugs that weren't like Node related at all. But I seem to recall seeing a spreadsheet from you that would indicate that there might be a significant performance benefit. So maybe that. I think the plan with Node 8 is when it goes to LTS later this year. Soon. October, right? November, yeah. Okay, sometime around then. Yeah. So the question is, do we keep track or monitor things like watch mode, developer experience related stuff? And the answer is yes, we do keep track of it. We ultimately, because we kept getting bit by this over and over and over again, have a laptop that sits on a desk somewhere that just runs these builds every 30 minutes or something off our master branch and looks for changes. I don't know that we have like, I would say that usually if there's a performance bug introduced, we had one recently that like broke watch mode. We find it pretty fast. And then it's a little reactionary, like somebody has to like drop what they're doing and go fix it, which is unfortunate. But at the same time, when we break it, it's usually like, we did this thing that we weren't doing before and we would have never had a test for anyway, because like it's a weird thing to add. It's a weird place to add a test. And it just like, in this one case, it broke watch mode. So I don't know if that's a satisfactory answer, but there's a little bit of yes and a little bit of we just usually catch it because somebody complains. It turns out if you got 120 developers or something using a tool every day, you find out pretty fast when something's broken. They're not shy typically. Actually, I say that, but it is amazing. Like we found it's pretty amazing what people will put up with when they think it might be just them and not everybody's experiencing it. It's like there's a separate talk here. Like we've had discussions and been trying to figure out how to get feedback from developers in a way that's like, it's not like this big heavyweight survey, but we get enough information to act on, and that we get it early enough that they don't spend an entire quarter stewing about this, and then our team gets destroyed in the quarterly survey for like how people are doing. I mean, like, you know, if the team gets destroyed, whatever, but like no, like, sorry. My point was, I mean, yeah, it feels bad when there's a survey where people are complaining about being unhappy for the last 3 months, but like, we also don't want you to be unhappy for 3 months, right? We'd like to fix it. We want to fix it. That's like part of the reason we enjoy working on this team, I think. I'm speaking for many members of my team who are sitting in the audience, but like that's why we enjoy it, right? That's like, it's not the bad parts. It's the making everybody happy and you know, getting rid of roadblocks and stuff. Yeah. So the question was, do we implement, or do we know of other? So what do you mean by all? Like how all? How all? Because we do actually have a fairly significant number of metrics that we track, and we have we've implemented like there are hooks in our CI build, which ultimately calls the Webpack build, that are sent, like deltas are sent to statsd. We have graphs for those. I imagine at some point there will actually be alerts on some of those things. Some of those metrics for our team in particular are actually considered business metrics. Like that's how our team is evaluated within the sort of company performance, is build related things in a lot of cases. A lot of them are higher level than like how long Webpack took. But for us, how long Webpack took is like 70% of what a developer is experiencing. So yeah. So the question was, do we all use the same sort of JavaScript variant or whatever, or do we use CloserScript, TypeScript, something like that? I'm pretty sure that it's all pretty vanilla, like ES 2015. Like we use Babel to transpile, but we've talked about TypeScript time and again, and it's like people have gotten excited about it. We had a hackathon where somebody worked on Flow. I think, was that you? I think it was you. Yeah. So we've talked about having like other flavors of JavaScript or JavaScript typing systems or whatever, but we haven't actually bit the bullet on it yet. Other questions? I mean, honestly, I'm kind of enjoying just standing up here answering questions, and it's kind of fun. So I can also sit down and we can sit in a circle or something. Yeah, I mean, does anybody have any horror stories? like I think honestly, my horror story is the one I told where we went from a 2-minute build to a 5.5-minute build, and it was literally change this word parallel to series, and like everything magically gets faster, which is not what you usually think when you think of going from parallel to series. But that was a good one. That's a good war story, I think. Yeah. 3-minute Webpack bundle with source maps, 10 megabyte bundles in production. Ours isn't quite 10, but ours is measured in megabytes. Yeah, no, it's so. I feel like a stand-up comedian at this point, because I want like how. I actually don't understand. Like we have pretty good introspective capabilities into our bundles, and I still don't understand where all this JavaScript is coming from. Like I can look at it and I can see that it's there, and I ask myself why, like where, like what is happening? Why is there so much? How do you end up with 3 megabytes of JavaScript minified? Like right? I don't even know. And it's not like, if we could have looked at it and said, oh yeah, there's this thing that we just don't need, like let's pull out 100K, we would do that. But that's not, like it's actually being used at one point or another. Crazy. Yeah. No. So the question was, are some of our resources lazy loaded? And the answer is yes. So we have 3 or 4 separate bundles on our details page. Oh, you two are on the wrong team. 3 or 4? I'm looking at you, Alan. Mm-hmm. Yeah, so 4 bundles. There's a vendor bundle that has, it's sort of an explicit list of things that we know don't change often that aren't our code. There's a common bundle that's shared between multiple pages on the site. There's the page bundle that's code specific to a particular page. And then for our details pages in particular, we split out, we basically organize them in such a way that we can say everything below this line is going to come in later. And that's all stuff that the user won't see at first load. So we can try to get that interactive as fast as possible. Yeah. Yeah, so the question was, is our above the fold bundle a bundle or is it inlined? I think that we have done experiments both ways. And I think right now it is not inlined. Yeah, so that's another thing that there's a work item to try and actually integrate it with our framework to be able to split sort of different chunks of the page into their own JS and then inline it when the HTML comes in from the server. That's like, I think they're calling that progressive web apps or something, where you send down some HTML and then the JavaScript that makes it interactive, and then some more HTML and then the JavaScript that makes it interactive. We're not doing that yet, but we're definitely interested in trying to in seeing if that makes the experience on our site better. But we haven't actually dug in yet, as far as I know, at least not completely. Yeah.
This is a horror story. One of our 60 entry points. One of our 6. Whoa, geez. Okay. One of our 60 entry points has 5,000 modules, and there are 60 more that are very similar to it. And so one of the big problems that we've been trying to figure out is how we actually profile to find things, because the profiler always the process never finishes because it runs out of memory. So it's like it's this hard problem. I mean, we can start with smaller things, but it's just an awful story.
Sympathize. That's so when I was writing this talk, one of the pieces of feedback I got early was like, hey, I like the talk, but can you put some numbers in? And I was like, well, it turns out if I undo all these performance improvements that we did, our build's never going to finish. So maybe I could like pick and choose some, and that's kind of what I did, and that's how I ended up with the numbers where they are. Yeah, Alan. Yeah, so just in case we're actually still recording this and somebody watches this far into it. So what Alan was saying is that the execution time of our giant Webpack bundle itself took on the order of 500 milliseconds, just for the file to be parsed and Webpack's like wrapper metadata thing that registers all of its modules to be executed. Which I think actually is a thing that other people have reported too. I feel like I've read that online in horror stories. I want to say that Webpack 2 or 3 has the ability to have some sort of flat namespace that's supposed to be better for that, but I don't know where that came from. I'm pretty sure I read it somewhere. I'm getting affirmative nods. So if I'm crazy, everybody's crazy. Yeah. How can you get the slides? I could probably share them or create a copy and share them. I'm trying to see somebody who actually knows the answer to that. Jen's hiding. Can we email the Eventbrite group or something, or message? Okay, yeah, you can try that. If that doesn't work out, I am robert.gay@redfin.com. If you email me, I will send you a copy of the slides. I think I can do that. I think I have the authority to do that. Anything else? All right. Thanks for hanging around. Thanks for chatting. I got some ideas for things that I want to try. I'll give another look at the DLL plugin in particular. And I'll be hanging around for at least a little while after this, so I got nowhere to be. So yeah, thanks.